Cool. So, hey everyone, back again to make the second video, the second LeetCode solution or second LeetCode problem. Um, I wanted to first make my first video, get some feedback, see if it would be useful to anyone, and from there, see if I want to continue making them. So I got quite a good amount of feedback saying that these could be useful. It's just another medium of uh, seeing people's thought processes. So cool, let's just dive into the second one. So here I got LeetCode open. I'm going to start with problem number 807, max increase to keep city skyline. It has a 79.9% acceptance rate and it's medium. So in a two-dimensional array grid, each value, grid I, j, represents the height of a building located there. We are allowed to increase the height of any number of buildings by any amount. The amounts can be different for different buildings. Height 0 is considered to be a building as well. At the end, the skyline, when viewed from all four directions of the grid, bottom, left, and right, must be the same as the skyline of the original grid. The city skyline is the outer contour of the rectangles formed by all buildings when viewed from a distance. And then they gave an example. So I need a minute to read this again because I didn't really digest what the problem was asking. So we're given a grid, a 2D array with the height of the buildings located in each index. We're allowed to increase the height of any number of buildings by any amount, and then the amounts can be different for each building. Height 0 is a building. At the end, the skyline, when viewed from all four directions of the grid, top, bottom, left, and right, must be the same as the skyline of the original grid. A city skyline is the outer contour. So a city skyline is the outer contour of rectangles formed by all buildings when viewed from a distance. See the following example. All right, and what is the maximum total sum that the height of the buildings can be increased? So they gave an input where we have, I'm just going to start writing this out. I have a screen share with my iPad open here. And I'm going to try to draw this out because viewing a 2D array like this won't really help. Well, actually, they have this. So we have 3, 0, 8, 4, 2, 4, 5, 7, 9, 2, 6, 3, 0, 3, 1, 0. And the output's 35. Why? The skyline viewed from the top or bottom, from the top or the bottom, is 9, 4, 8, 7. Okay. And the skyline viewed from the left to the right is 8, 7, 9, 3. So it's taking the largest number from each row or column, depending on where you're viewing it from. And the grid after increasing the height of buildings without affecting the skylines is 8, 4, so 8, they increase this by 4, 8 and 7, they increase 2 of these to be 7, this one they increased to be okay, and then everything became 3 here. Alright, so I kind of see what's going on because now when you view it from the top, it's still going to be 9, 9, 4, 8, 7, which is what we had here. And from the left to the right, it will be 8, 7, 9, 3. Yeah, cool. So they gave some, I guess, constraints. One is less than the grid length, or the amount of rows. 1 equal to, okay, and then this one, the amount of columns is going to be less than or equal to 50. Okay, so never mind, I read this wrong. So it's going to be a square 2D array with a length greater than 1 and less than or equal to 50. The numbers inside are in the range 0 to 100. All buildings in grid I and J occupy the entire grid cell. So what does that mean? All buildings in grid I, J occupy the entire, that is, they are one by rectangular prism. Okay, so like if you have 4, it's like taking up this whole index as a building. Cool, that means that they got, when understanding the problem, like if I were to ask a clarifying question in an interview, I might ask if any of the numbers could be negative, and what are the boundaries, stuff like that, but that stuff's already given. So on to, I guess we already understood the problem, the matching phase. I'm thinking there's not like an external data structure we can use for this problem, but we would have like, I guess, pointers pointing to each index that we need to see. I still, in my head, I'm not really sure of how we'd go about solving this, so I want to think about it. So when viewing it from the top, okay, we want to keep these to be the same. So I guess the first pass, we can do a first pass through the 2D array and see what our arrays are going to be like. Let's see, would that make sense? Because we want this one to stay 9 and then this one to stay 8. So we take the lesser of the 2 and we can increment all these other ones. Is that true? No, it's not, because this one is 4, and if we made this 8, then this row would become 8. Let's see. Assuming we have this, let's assume we have that. What can we do? You'd have to do a check every time. Can this one be incremented? Because is it greater than 4? So let me try drawing it out. That way I can mess around with it. I'm going to take this array that was given. So we have 3. Okay. Cool. My pen wasn't working. Now it is. 3, 0, 8, 4, and then 2, 4, 5, 7, 9, 2, 6, 3, 0, 3, 1, 0. Alright, so we have this given to us, and when we go through it, we know that from the left and right, it's going to be 9, 4, 8, 7. From the top bottom, it's going to be 9. Oh wait, from the left and right, when you view it from the left and the right, it's going to be 8. So I mix the 2 up. This is going to be top bottom. This one is going to be left right. So from the left and right, it's going to be 8, 7, 9, 3. Sorry for my messy handwriting. I'm just kind of scribbling. Cool. So when we start off here, what can we increment this to? We know that it can't be greater than 8 because we have an 8 here, and it can't be greater than 9 because we have a 9 here, but we're going to take the lesser of the 2. So we can add 5 here, and then we'll keep a counter as we go along, so like counter becomes 5. Then we go to this index, we see we move this way, so we keep 8 in our I guess like point of view, but we also then take the next greatest element, which is here, 4. So it can't be greater than 4, and it can't be greater than 8. So we can increment this by 4 to become 4. So plus 4. And now we can remove this circle. We added 4 here. Let's just keep a counter. 8. We can't increment this because it's our greatest, so we can't go higher than 8. So that one's done. Now we're at the 4. It can't be greater than 8, and it can't be greater than 7 because this is here. So what we can do is add 3. And then we move on to the next row. So now we're looking at this 2. When we have 2 in consideration, we have to keep into mind 9, and we have to keep 7 in our minds. So here we can increment by 5 to make it a 7, plus 5. Moving along, we will move on to the 4. So 4 is the largest here. We don't want to increment it by anything, so 0 is there. It's the largest for this column. 5 here can't be larger than 7, and it can't be larger than 8, so we can add 2 to make it 7. So plus 2. And then 7, since it's the largest of this column, we can't increment. We leave it alone. Moving on to the next row, we have 9. 9 is the largest in this column, and we already know that. So we can continue on. Moving to the 2, we want to keep this 4 in mind, as well as this 6. So we can add 2 to this, because we can make it a 4. So plus 2. Let's go ahead and erase this. And now we're at the 6. So here, when, I think I circled the 6 earlier, but it was actually the 9 that we have to keep in mind, because it's the largest. But now we're at the 6, so we have to keep this 9 in mind, and we have to keep this 8 in mind. So we can add 2 to make it an 8. Moving along to the 3, we have 7 and 9, so we can add 4 to make it a 7. Now starting at the 0, we want to keep this 9 in mind because it's the largest for the column, and we want to keep this 3 in mind because it's the largest for this row. So looking at 0, we can make it a 3, so we can add 3 to it to make it 3. This 3 is the largest for this this row, so we'll move along. We can't do anything here. Let me just go ahead and, I think I added plus 4 to make this a 7. This one was a plus 2. Yeah, I forgot to write these in. This one is a plus 3. So plus 2, let me just go 5, 4, where's this 3? So I believe this one was plus 3. 3, 5, 2, 2, 2, 4. My bad, I wrote plus 7. I meant to make it a 7, so plus 4. Here plus 3, now we're looking at this 3, it's the largest of this row, we can't do anything with it. When we look at this one, it can't be greater than 3, and it can't be greater than 8. So we can just add 2 to it. And finally this 0. Can't be greater than 7, and it can't be greater than 3. So we can just add 3. And we add 3. So let's go ahead and sum these up. So this is going to be 7. This 5 and 5 is going to be 10. This is 6 plus 4 is 10. This is 5, and let's leave this 3 here. We'll take the 7 and the 3, make it a 10. Plus 10 is 30, plus the 5 is 35. And when we see, that's actually the output that they wanted, 35. And that's what we got, where we see right here, this 35 here. So it seems like we understood how they got the solution. We can also check if our grid matches. So our, let's see, let me put this here. So here we have 3 plus 5 is 8, which is the 8 here. 0 plus 4 is 4, 8, 7, 7, 4, 7, 7, 9, 4, 8, 7, 3, 3, 3, 3. Okay, cool. So yeah, we got what we wanted, the new grid. And we see that here, this function or method is returning an int. So I'm guessing that's just the output, this how much we incremented it by. So cool. We have, I understood the problem. There's not really an auxiliary data structure we can use. I mean, I guess thinking about it, when we're incrementing index by index, we're incrementing the number in that index. We'd have to do a check every single time to see what the greatest is for the row and the column, and that's pretty inefficient. We can maybe do one pass the first time to store that somewhere, and then we can just view it later on, such as in this way where we got this. That might be a good idea. That way we don't have to keep on looking up every time. We just, if we're moving left to right, so for this 3, 0, 0, we look at this 0, this 0. So you want to look at, yeah, and then take the lesser of it, and then move along, and then 0, 1, the index 0, 1. We want to look at this one, and take the lesser of it and sum it. And then when we're here, we want to take a look at 8 and 8, so 0, 2. That would be, you'd look at 8 and 8. When we're at the 4, so 0, 3, index 0, 3. We're going to look at the 8 and the 7, take the lesser, and do the subtraction. Seems like this is working, and it saves us a lot of time in checking what's the top and bottom. So when we're at finally index 1, 0, we'll take a look at the 9 and the 7. Yeah, sounds good. Let's create the pseudocode for this. So what we did first was, we're in a plan pseudocode phase now. Let's create the 2 arrays of the get, top, bottom, and left, right views, Skyline views. Next would be, basically the high level overview would be get those views, and then increment to min of the 2 indices. And then these can be broken down even more how we do that. So the Skyline views, we just, how would we do that? Let's see. So given this 3084, when you're here, you want to just go row by row. So first you do the top bottom, you'd iterate through the thing, through the array. And for this column, you'd just see that it's 9. For this column, it's 4. For this column, it's 8. For this column, it's 7. Okay, so it seems pretty simple. And then for this column, it'd be 8. This column would be 7. This column would be 9. And this column would be 3. So by doing that, we save ourselves the time of traversing through the 2D array to see if it's bigger or smaller. And actually, it instead of doing an n by n big O time, we get an n plus n O time, because it's just n and then n. Big O, obviously. That's what we're talking in here. Can't write. Okay, cool. So by doing that, we save ourselves the time, and it allows our solution to be more efficient. Okay, so pseudocode for this would be keep track of largest for each column, table squeaking. And then do the same for each row. And we can maybe like modularize this by having a helper function that'll just return a 2D array with like two rows and then whatever the amount of columns is. And then for this one, increment to the min, we kind of saw how we did it here, where as you're incrementing, or as you're moving along each row, so 0, 0 to 0, 1, 0, 2, you're going to keep your left-right view the same, but you're going to increment this top-bottom view. And then when you move down the row, you want to increment this left-right. Cool. So let's try implementing this. I'm going to close this a little, make some space for myself. And so the first thing we did was get the top, bottom, and left, right view, skyline view. Here, let's just say int this is going to equal, and that squeaking noise is really bothering me. Let me see what I can do about it. Cool. Hopefully this helps. So we get this view, skyline views is equal to get skyline views. It's getting worse. Get skyline views. So this would be a private integer array, returning integer array. Call it get skyline. Great. Let me see if I can move to this side of the table. Get skyline views. With this, we'll pass in the grid. So we'll take in an integer array, a 2D array called grid. And let's initialize the thing we want to return. Let's just say skyline view is equal to a new int, and the size is going to be 2 rows, and it's going to be grid.length columns, and then for we're going to iterate through the, here we'll iterate through the, let's see what we did first. Here we did top and bottom first, so TB to do top bottom, the views is going to be, alright, cool. So we're going to go through the columns. Grid dot, or grid, let's just say 0 dot length, and we'll say skyline view 0 I is going to equal, or hold up, we want to keep the count, or the sum of the largest number. So largest is equal to 0. Yeah, because the range is 0 to 100. So as we're iterating through, if grid 0 I see. I did it the other way around, I guess, but that's fine. This is going to be left to right view. So basically, so it has to be a 2D array for int j is equal to 0. Grid.length, j is less than grid 0 dot length j plus plus. This goes in here. Let me just make sure why I'm doing what I'm doing. I kind of lost myself, in fact. All right, so we're going through the row, each row, and getting the largest. Okay, yeah, so it's not going to be a 2D. I is less than grid dot length, and we want to do this for every column, you want to have a largest counter, or a largest variable to keep track of the largest. And then for every one of the columns, am I right? 0 dot length, okay. So for every column, then go through, okay, yeah, cool. And then if the value in this index, so the value at j, I know I kind of flip-flop them from like standard ways we use them. We normally use I and j, but that's fine. So if this is greater than the largest, set largest equal to grid j I. Let's go ahead and just swap these so that we're like used to normal convention, because I know that will probably throw me off soon enough. Forgot the I++ here. Change this to j. Cool. So the largest is equal to this, and then finally you want to set, let's just keep this. All right, actually here. Skyline view 0, I is going to equal largest. We want to do the same thing for the left-right view. So let me just go through this now, seeing how this would work. So for int I equals 0, I is less than the number of columns, I++. So I is equal to 0, yeah, cool. And then j is equal to 0, j is less than the number of rows, j++. So if ij is greater than the largest, set largest equal to that. So we'll say largest is 0. I'm going through this, grid pointing at 0 on the column, and then 3 is greater than 0, so set it equal to 3. Continue through this loop, so we've incremented the row we're on. So 2 is not greater than 3, 9 is greater than 3, 0 is not greater than 3, so we're done with that one, and then we'll set Skyline view of at index 0, because that's the first one, equal to 9, and then we'll continue on. So just to make sure, my two arrays are going to be, this is my top bottom view, and then this is my left right view, and I want to write that down so I remember for later on. And now we do the same thing for the rows. So we'll just flip these around. Grid 0. Oops, I put a no. If, okay, so now this is equal to this. For j is equal to 0. J is less than the number of columns. If it's greater than the largest, set this one equal to 1. All right, cool. So now that we've got that, we want to return Skyline view. So with this, as we will now, this is where we increment to the min of the two indices, increment to min of the two indices of views. All right, so keep track of amount incremented totally. So let's just call it in counter is equal to 0. Now that we have these, we can basically iterate through the grid. Grid.length I++. And now for j is equal to 0, j is less than grid 0.length. And we can do this because it's a square matrix, j++. What we'll do is keep a left, right, and a top, bottom counter. So here we'll have int lr ctr is equal to 0, int tb ctr is equal to 0, and we want to actually have this tb be reset every iteration of the second loop. We'll have this lr++. So now let's take the min of the two. So here, at the end of these, we will do tb++, and we will say counter plus equals the difference between the two. So grid, or the min. So I believe it's math.min, and then we put the 2. So we'll pass in Skyline views, and we said that it's TB and then LR. So TB, or actually 0, and then, so 0 was the TB counter. Okay, TB counter and Skyline views 1. Just minimize this. And TB counter minus whatever we have at grid I, j. So if we have, when we went from 8 minus 3 is 5, and we'd add that. And eventually at the end, we just return counter. So let's run through this with a smaller array than this large one that was given to us. Let's run through it with our code. All right, so let's just say we have a, make this bigger. Let's just say we have a 2 by 2. 1, 2, 3. Let's say 1. So when we run through this in like pseudocode without using our code as a guideline, our top bottom view would be 3 and 2, and the left, right would be 2 and 3. Yeah, correct. So this is top, bottom, and left, right. So then we want to add the minimum of these two because we're at index 0, 0. We'll look at 0, 0, and we'll look at this one. So it's fine, I don't need to write this down. And then we'll increment the 1 to be the smaller, the min of the 2 or 3. So we increment by 1, and then we move on to the next, we'll move on to the 2. So here we'll look at this 2 and the 2, and we'll see that math.min of these, 2 minus 2 is going to be 0, so we'll add 0. Next one, we'll look at this 3. So when we do that, we actually move along to this one, and we shall look at 3 and 3. So math.min minus that, it gives us 0. We'll move on to this one. It'll give us, we can increment to 2 because it's the min of 3 and 2. So this one can just be incremented by 2, leaving us with 2 and 2 on these places where the 1 is. Using our code, we can try to run through it. Let's see. So I'm going to assume we did the get Skyline views like this, and our code actually returns this as a 2D array. So I'm assuming that this works. Let me set my counter equal to 0. And then we have a left, right equals 0. We have a top, bottom equals 0. So we're going to iterate through this mini grid that we have, 2 by 2 grid. So I is equal to 0, j is equal to 0, and we'll take the counter. We're going to add in math.min of Skyline views 0 at TB counter, which is right now 0. So 3, min 3, and Skyline views 1 at TB counter. So 1, and TB counter is 0, so 2, which is correct. Minus whatever the index is, so minus ij, which is right now 1. And that means we add, this becomes 2 minus 1 becomes 1. So we'll add counter now becomes 1. Here we incremented the TB counter, so it's now 1. And we see that we do counter plus equals the min of 0, 2, so min of 2, and 1, 1, so 3. And is that actually, no, so here when we're looking at this index, we're comparing 2 and 3, but which should not be the case. And I kind of see why that's happening. This is the left-right counter, LR counter. Because we only want to increment the TB counter as we go along the columns, and the left-right counter as we go along the rows. So, all right, assuming I fix this properly, let's take a look at this again. Now, instead of doing 2 and 3, we'll do 2 and 2 minus 2, which is 2 minus 2, which is 0. So counter stays the same. TB counter becomes a 2, and we are at index 2, which isn't it won't go in through this loop again, and TB counter becomes 0. And the LR counter becomes 1. So now we look at this I is 1. This we look at in this 2 here. This 3 here. So we'll take a look at min of 3, or actually this is 3 and 3 minus 3, which is 0. And for this one, we'll look at TB counter becomes 1. We'll look at min of 2 and 3 and minus 1, which becomes 2, minus 1, which becomes 1, and then the counter becomes 2, and we return the 2. So it seems to have worked when I ran through it in that mini example. Let's go ahead and try running the code. So I got 32 instead of 35. Let's see why. So looking at my code, I ran through this assuming that my get Skyline views was returning the proper, it worked properly, but after taking a look at this code, I realized I'm doing the same thing here, essentially as I'm doing here. So this Skyline view 2D array with the 2 rows is essentially just returning the left-right view on both row 0 and row 1. And I realized after thinking about it that it's because I'm doing grid at index I and j both times. So simply to fix that, to do column instead of the row first is ji, and that should fix it. So I had 32 and 35. I believe this one works as proper. It was this function that actually was giving me like a little tricky, causing me a mess. Let's run it now, and okay, cool. So 35, it's the same as 35. Worked for this one. Our code works. It's not pretty, but it does work. Let's see if it accepts it. Cool. So our submission was accepted. That means we've implemented it properly. We can go to the review. So I started off, not having these values stored, and I was doing a look every time to see what the new, or what the old and what the largest of the columns and the row were every single time. By doing that, we kind of saved some time, but in the end, the big O notation of this would still be big O of n times n, because we have to go ahead and touch all n by n elements. But because we also cached these values, we introduced some space, which is going to be big O of n, because it's just 2 rows, which, I'm not sure how much better it is in that case. Like, we noticed that it improves our time complexity, not in big O notation, like asymptotically, but just in the general amount of time it takes. But now we've introduced the space. So that's something like we can talk about with the interviewer. I think, yeah, this would be what I would submit to like an interview. I evaluated the big O time, what I can do to improve it. Let's see. Not really sure what I can do to improve it. We can take a look at some of the solutions that were already pushed. So row and column maximums, I believe this is what we did. Time of n squared, space complexity of O of n. It's the exact same one that we did actually. theirs is a lot prettier. So row maxes are in grid RC. Okay, I see what they did. Yeah, theirs is a lot prettier, definitely. Um, that's something I want to work my way up to, but they did the math.min, same as I did. And this, okay, got it. I see what they did. It's a lot prettier than mine. Something I want to work up to, definitely. I know this video, it took quite a bit of time in solving this problem, even though it has a high acceptance rate. I'm assuming also because it's a medium, but I think I did it in 45 minutes, which is the amount of time it would take in an interview. And I feel like I was pretty verbal about like my thought process, and I know I took a while in working it out. Um, but yeah, I hope these videos like do provide some help to other people because I know it's definitely helping me. Um, I get kind of nervous when I have to talk my solutions out and talk on video or in person. But by doing these, I feel like I can definitely get over that fear of being judged and like whatever. So cool. See you guys in the next video.